Hi, today we are going to learn more about the circle theorems. So today we are going to have a look on the key points, the rules, the properties and the theorems which are used in the questions regarding finding angles within a circle. So the first theorem that is very important is the angle in a semicircle is 90 degrees. In this circle, the diameter is dividing it into a circular arc. So the angle subtended by the semicircle is 90 degrees. Coming to the theorem number 2, the angle subtended by an arc at the center of the circle is twice the angle at the circumference. Now, we have three cases, one with minor arc, the other with major arc, and the one with a semicircular arc. Now, the circle number 1 is representing minor arc. The minor arc AB is subtending two angles. The angle which it is subtending at the center of the circle is 2 theta, whereas the angle which it is subtending at the circumference is theta, because the angle at the center is always double as compared to the angle at the circumference. Now this is also known as arrow rule, because here you can see that an arrow has been formed. So whenever you come across a question in your exam in which you have found this arrow, then you can use this rule over there. Now coming to circle number 2, there is a semicircular arc and it is subtending an angle of 180 degrees at the center of the circle, which is basically the diameter, whereas this semicircular arc is subtending an angle 90 degrees at the circumference, which is clearly half of the angle at the center. Now coming to the circle number 3, this is major arc, and one thing that you should always remember is that minor arcs are associated with angles less than 180, which is given in circle number 1, whereas in circle number 3 major arc is given which is always greater than 180 degrees. So the angle which this major arc is subtending at the center of the circle is double as compared to the angle subtended by it at the circumference of the circle. The next rule is cyclic quadrilateral. Now in this figure you can see that this circle with a cyclic quadrilateral, and the cyclic quadrilateral is the quadrilateral which has all of its four vertices lying on a circle. As you can see that these are the vertices A, B, C and D, and four of them are touching the circumference of the circle. So the property associated with cyclic quadrilateral is that the sum of opposite angles of a cyclic quadrilateral is 180 degrees. So in this case we can see that the opposite angles A and B sum up to 180 degrees because they are supplementary. And in my videos you can watch where I have used this rule frequently. Another important thing that you should know about circle is tangent. Now, tangent is the line touching the circle. A tangent to a circle is a straight line which touches the circle at only one point. Now, this is the straight line AB which is touching this circle at the point C. So this straight line is tangent, whereas OC is radius. And the tangent always makes an angle of 90 degrees with the radius, that is the right angle. Another important property that we use while solving circle questions is about isosceles triangle within a circle. First of all, I want to tell you that what is an isosceles triangle. So an isosceles triangle is a triangle that has two sides of equal length. Like this, in this isosceles triangle, I have marked the equal sides with double line and the base angles are equal. Now in this circle, these two are radius of the circle, so we mark the radii with R, these two are equal in length and therefore their base angles will be equal. This is a rule that is frequently used in circle-related theorems in which you have to find the angles. Now, last but not least, butterfly rule. Now, this is a very interesting rule which states that the angles in the same segment formed by a common chord are equal. Now, in this part, you can see that AB is a chord and these are two angles ACB on one side of the chord and then ADB on the same side of the chord. So these two angles are equal. If we draw another angle within this same segment, then it will always be equal to it, like this. This is also